Hi everyone, welcome to Ms. Sawagid's math class. Today we will be solving inequality by graphing. For us to understand that, let's review one thing. How do you solve equations? By graphing. I will start with something simple that we learned before. If I have y equals 2, that's an equation. How do I graph it? We remember that if you have y equals a number, it's a horizontal line crossing the y at that number. So go on the y-axis, find positive 2, and now draw a horizontal line. That is your solution to this equation. Every coordinate on the line is a solution. For inequality, means you have more than or less than. So how do I graph y more than 2? Now I need to decide where are the solutions to this inequality. Are they above the line on the coordinate plane or under the line on the coordinate plane? Let's see, I need y more than 2. All numbers more than 2 will satisfy this inequality. So I will shade every number above the line because those are the solutions for this inequality. Now let's talk about the line itself. This line is called the boundary line. Is this boundary line included in the solution of this inequality? Y more than 2, but this is a line for y equals 2. So how do I make it just more than 2? Because it does not have the equal sign on the inequality. By, instead of drawing a line, now we make that line dashed, which makes it, now you have a dashed line instead of a solid line. So this boundary line, when it's dashed, not solid, it means it's not included in the solution for this inequality. Now how can we graph this linear inequality? Negative x plus 2y more than or equal to 2. If you remember, this is written in standard form. So the easiest way to graph this is to find the x-intercept and the y-intercept. To find the x-intercept, from previous lessons, cover the y because y has to be 0 for the line to cross the x-axis. So if I cover the y, you end up with negative x more than or equal to 2. I don't want negative x, I want positive x. So multiply by negative 1 both sides to get rid of the negative. Because negative times negative is positive, so you end up with x. Now remember to switch the signs. When you're multiplying or dividing with a negative number, you have to switch the inequality. Now x has to be less than or equal to negative 2. So go on the x-axis, find negative 2 and put it down. Now I need to find the y-intercept. To find the y-intercept this time, I cover x because x has to be 0 for the line to cross the y-axis. So you got positive 2y more than or equal to 2. Divide by 2 to isolate y, you end up with y more than or equal to 1. So that is your y-intercept. Go on the y-axis and put a dot on the 1. Now follow the slope. If you remember, you're going up 1, right 2, go up 1, right 2, up 1, right 2, up 1, right 2, or go down 1, left 2, down 1, left 2, down 1, left 2, and connect that line. Now I need you to think about, is the line a part of a solution? Yes, because you have the equal sign in the inequality. Now I need to decide which part of the coordinate plane do I need to shade as a solution to this inequality. I need to add those two numbers to be more than 2. And the part that is more than 2 is the upper part of this coordinate plane or on top of the boundary line. So I would shade this area above the boundary line. But how do I know if my solution or my shading is correct? You would check the origin and see if it works. Here, for example, the origin is 0, 0, which means X is 0, Y is 0. If I substitute those numbers in the inequality, the original inequality, does it make it true? Let's see. If I have negative 0 plus 2 times 0, is it more than or equal to 2? I'm checking to see. Negative 0 or positive 0 is the same as 0, and 2 times 0 is 0. Is 0 more than or equal to 2? That's not a true statement. That means the origin is not part of the solution, so don't shade it. My shading is correct. And everything above the boundary line is a solution. Now watch how the boundary line itself is solid. So this is a solid boundary line because every dot on the line is a solution, so it is included because it does have the equal sign with the inequality. Here's a word problem to solve. You can spend at most $10 on grapes and apples. Grapes cost $2.50 per pound and apples cost $1 per pound. Write and graph an inequality. I have a maximum, which is $10. This is the maximum I can spend. So I know I have to be spending equal to 10 or less than 10. So whatever combination I have, it has to equal or be less than $10. Now let's write the X, the variables, and I know my variables. The X represents the number of pounds of grapes I can buy, and the Y represents the number of pounds of apples I can buy. Now let's look at the cost for each kind of fruit. The X, which is the grape, costs $2.50 per pound. So how many pounds can I buy for $2.50? So $2.50 times X, which is the number of pounds, plus how many pounds of apple I can buy. Each one costs $1, so 1 Y. So the combination of $2.50 for X plus the $1 for the Y has to equal or less than $10, which is the maximum I can buy. How do we solve this? Again, since it's in standard form, find the intercept. So I find the X-intercept by covering the Y, because Y has to be 0 for it to cross the X-axis. Therefore, 250 X less than or equal to 10. Divide by 2.5, both sides. That gives you X less than or equal to 4. That means I will go on the X-axis, find 4, and put a dot, because that is the maximum number of pounds of grapes I can buy for $10 without buying any pounds of apples. Now let's find the Y-intercept. The Y-intercept, this time I need to cover the X, because X has to be 0 for the line to cross the Y-axis. If I cover X, now you have Y less than or equal to 10. Now I will go on the Y-axis, find 10 and put a dot. That means this is the maximum number of pounds of apples I can buy for $10. And think about it, if it costs you $1 a pound, 10 pounds, you already spent your $10. Now, is my line dashed or solid? Since you have an equal sign with the inequality, to graph it, you need a solid line. So connect the two dots with a straight line. So my boundary line would be solid to include all possible solutions that is on the line. I cannot exceed the 10, I cannot exceed the 4, so I know I need to shade this side. So shade this side. And everything inside of the shaded area is a combination of both number of pounds of grapes and number of pounds of apples, paying this cost with a maximum of $10. Now, how do I check if I shaded the right area of the graph? I would check the origin, which is 0 pound of grapes and 0 pound of apples. This is the X, this is the Y. Substitute them in the original equation. Does it satisfy that equation? Does it make it true? 2.5 times 0 plus 1 times 0 is
less than or equal
10. Is this a true statement? Let's see. 2.5 times 0 is 0. 1 times 0 is 0. Is it less than or equal to 10? Yes, 0 is less than or equal to 10. So I did shade the right area because the 0, 0 is included. Now, in conclusion, solving linear inequality, you follow those steps. Use a dashed line. The boundary line will be dashed if the inequality is more than or less than. Use a solid line. So the boundary line would be a solid line if the inequality is more than or equal or less than or equal. Check if you shaded the right portion of the coordinate plane. How do you do that? The easiest coordinate pair on the coordinate plane is the origin 0, 0, where x is 0, y is 0 in the original inequality, and see if it makes it true. If the 0, 0 included in the shaded area, then you shade that part. If the origin is not included in the shaded area because it's not a solution, then it should not be shaded. What if the boundary line crosses the origin, which is 0, 0? So do I shade above the line or under the line? You check any coordinate pair other than 0, 0 to see if it satisfies the original inequality. If it does, then you shade it. If it doesn't, you just don't shade it. That's it for today's lesson. Thank you for listening. Have a great day.